All right, product rule, quotient rule. This is 826. So we learned in previous sections that the derivative of a sum or a difference is simply the sum or difference of the derivatives. That sounds complicated, but it's really quite nice and quite easy. If you want the derivative of two things that are being added, you can take the derivative separately and then add them back together, which is nice. We use this all the time without thinking about it for things like this. Like there's no magic to finding the derivative of sums. You just find all the individual derivatives. Plus 36x squared minus 17, and then add them or subtract them. Like we don't hardly give any thought to it. But things are different if it's multiply or divide. So what if instead of a sum of terms, we have a product of terms? So we're multiplying. So we want to take the derivative of f times g. It would sure be nice if the derivative of f times g was just the derivative of f times the derivative of g. Like that would make things really easy in our world. Yes. But it doesn't work that way. So we're always mixed about whether we even include that statement on the notes, because if you're not paying attention and you just look at it, you're like, oh look, let me box that up. There's the product rule. Like, no, that is not the product rule. That doesn't work. If you're taking the derivative of a product rule, here it is. The derivative of f times g is f prime g plus g prime f. So another way to write it without all the parentheses would be like that. In words, it's the derivative of one of them times the other one plus the other way around. How's that for a formula? So we can see it. It's the derivative of one of them times the other one plus and then the other way around. And because it's adding and multiplying, the order doesn't matter so much. So it's not that big a deal if you get these out of order, as long as you have one derivative and one original plus the other way around. So I'll try to always do it like this to match our formula, but later in the year I don't remember that formula in that order. I just know that it's one of them times the derivative of the other plus the other way around. Examples. Okay, well, one way to solve this would be to like multiply all that out and then do derivatives, but that would be kind of yucky.
Yeah, that's what I think we do for class.
So, I mean, it would work, it just would take a while. Instead, let's say this first function is f, and we'll say that second function is g. So let's find their derivatives separately here. So f prime and g prime. So find those. And those are very straightforward, so I don't feel bad at all about picking on some people to give us those. Kira eagerly checking her answer, which is fine. Caleb's going to check his answer, I imagine. Or is he just confident? Got it. All right, Kira, what's f prime?
4x to the third minus 6x plus 9.
Good. Caleb, what's g prime?
10x to the fourth plus 4x to the third.
Good. Good reminders there. And so now to find f prime, let's see, we have to do f prime times g. Spreading this out because I already see that f prime and g all the pieces are long, plus g prime times f.
Yay.
So let's see, f prime, stick with the color coding here, 4x cubed minus 6x plus 9 times g,
You okay?
2x to the 5th plus x to the 4th minus 12 plus, then I got to go the other way around, g prime 10x to the 4th plus 4x cubed times the original f so that's a giant mess, but maybe it was better than multiplying 3 terms times 3 terms.
Terrible.
Product rule. One of
I'd
them.
rather have you just multiplied each piece out.
Number 2. Find. I mean, it's fair to say this class is work. So let me just hit pause. Find the instantaneous rate of change. Again, that just means derivative of y equals x cubed sine x with respect to x in terms of x. That's a lot of words that just means find dy dx. So let's identify who f and g are. So there's f. There's g. So I'll find the derivatives of f and the derivative of g and then put everything back together. What was that, Ty? How do you know which one's which?
Yes.
Yeah.
That's a good question. Let's see. The product rule is anytime you're trying to find the derivative of two things that are being multiplied together. So it doesn't even have the multiplied in there, but those are two separate functions being multiplied. One of them's f, one of them's g. If you call them the other way around, it won't matter because all you're doing is adding and multiplying. So if you put them, I don't want to say backwards because it's not wrong. If you put it the opposite, it's okay. But we almost always label the first function f and the second function g. So let's get some help here. Mia, what's the derivative of f? 3x squared. Miguel, I guess you get the harder one because we only learned it yesterday, but what's the derivative of sine? That's okay, look it up.
Because I'm cheating anyway.
So you have to memorize
Cosine. So you've got to memorize. You have to have the trig functions memorized. Alright, so dy dx equals f prime g plus g prime f. And I'm writing it real spread out so that I have room to put everything in. So f prime 3x squared. G is sine of x. G prime is cosine of x. And f is x cubed. So not hard, just be careful. Also, we usually don't put the x cubed at the end because then it's not real clear of like what exactly we take in the cosine of. So we'd probably write it like this. Just to put the x cubed on the front. Number 3. What is the slope of the line tangent to the curve? Meaning, find the derivative of this thing when x equals pi over 3. Cool, this one's a little different because we got a 6 out front. 2 ways to handle that 6. And they're equally fine. I need to identify who the f and the g are. I think the g is easy. That's got to be tangent of x. The f, you can make f equal to just sine, and then just kind of put 6 out front of everything. Or you could attach the 6 to the sign and call that all of that f. Turns out the same either way. You got a preference? You may not. What's that?
Just keep it with that.
Keep it with f? I think that's the easier way to go. And I think that's what most people would pick. So I'm going to make f be 6 sine of x. And g be tangent of x. And I'm going to have to move over here a little bit to make room for all of this. So I need f prime and g prime. And then we'll put it all together. So f prime and g prime. Uh-oh, Maria today. Kyle and Garrett. Kyle, if f is 6 sine x, what is f prime? What's that? Almost. We want to include the 6 in there. We want to include 6 as part of our answer. 6 cosine x. Garrett, how about the derivative of tangent? Secant squared. Oh. Miguel admitted it. Maybe the most of you are still doing it anyway, looking it up, and that's fine. It's okay. But again, we got to get to the point where we know those trig derivatives. So let's see. G prime. This is a little bit tricky because I used f and g when g is already the name of it. That's fine. Just be careful. So f prime g plus g prime f. So f prime is 6 cosine x. G is tangent of x. Plus, the other way around, g prime is secant squared x. And f is 6 sine of x. And then, I don't know, there's some algebra type things you could do in there that might simplify, but most of you would probably just plug in pi over 3.
So for multiple choice, like in last unit, the multiple choice ones are more simplified than
Right.
the stop points. Is that going to be the same way this unit?
Yeah. So that's a perfectly acceptable, well, not for this one because we still need to plug in pi over 3. But if it didn't have the point, free response, I'd leave it like that. Like, why risk messing up some pre-cal trig stuff? But multiple choice, let's see, tangent is sine over cosine, so maybe the cosines cancel. I don't think anything over here would really do anything. I think I'd probably just plug it in. Alright, pi over 3. That's right there. So cosine of pi over 3 is 1/2. Tangent of pi over 3 is square root of 3. Secant of pi over 3 is the flip of cosine, so that'd be 2 and then squared, times 6 times sine is root 3 over 2. Probably should label that better. That's now g prime at pi over 3. And that's a safe stop. So on a free response question, like, why risk messing this up? I'm done, walk away. Multiple choice. Let's see, that's going to be 3 root 3 plus 4 times 3 is 12 root 3. So 15 root 3. We want a simplified answer. F prime g plus g prime f. I'm going to leave number 4 alone just because it's this combination of things we've already done. So, product rule. F prime G plus G prime F. Turn the page. Quotient rule.
Yay.
A little more complicated than the product rule. That makes sense because division is always more complicated than multiplication. F prime G minus G prime F all over G squared. I remember it this way. GF prime minus FG prime over G squared. That's the same thing. I switched the order of the G and the F up there. Or the G and the F prime. This one's more important to be careful when you memorize it because of the minus sign. You got to get the right guy first. It matters. In addition, if you got him backwards, who cares? There's not really a backwards in addition. But there is a backwards in subtraction, so you've got to get the order right on this one. So GF prime minus FG prime all over G squared. So again, you're going to label the top one's F, bottom one's G, and you, for now anyway, you've got to take the time to show F prime and G prime. It's just too much to try to skip all of the steps. So here's some good review questions here. But these are just power rule problems. So Brooke can tell us that if F is 5x minus 2, then Brooke, what's F prime? Yes? Say it with more confidence than that. But yes, it's 5. Peyton, if G is x squared plus 1, then G prime is 2x. Good. All right, so GF prime minus FG prime over G squared. Just be careful like this. Let's see, G is x squared plus 1. F prime is 5. Minus F, 5x minus 2. G prime is 2x. And then G squared, just take the denominator and put a squared on the outside. And safe stop, we're done. Multiple choice, I guess they could distribute it and look for things that might cancel. So let's see, that'd be negative 5x squared plus 4x minus 5. But I would get to a safe stop, and then you start looking at your answer choices and see if that's there. Hopefully, if it's not there, then you got to do some algebra and see if you can run into that answer. Number 2. Find the instantaneous rate of change. Again, we just keep hitting you with the different words for derivative of that function with respect to x in terms of x. So the top is f, the bottom is g. So we need to find f prime and g prime and then put it all together. So see if you can take that one from there. Later, it might be useful to factor out x from the top, but I don't even think we would do that yet. Questions on that one? So yeah, formulas. A lot of formulas yesterday and today. Just new stuff you just have to commit to memory. So this is a good time to, put it on a flashcard. Quotient rule. Put product rule on a flashcard. Make 6 flashcards with each of the trig functions, and go through them this weekend some to make sure that you've got them down. Let's do one more of these. Let's do 3 because it looks worse than. Oh, you know what? Let's do 4. Because something happens on 4 that is good news, but it feels like weird news when we first do it. So f is the top, g is the bottom. So I need to find the derivative of the top, derivative of the bottom, and then put it all back together. Okay, so you can't just find derivative top over derivative of bottom. That's not the quotient rule. Take and roll as I pull popsicle sticks today. So, Marissa, what's the derivative of f? If f is 7, what's the derivative of 7?
0.
Yes. Did you know that before Brooke mentioned it to you?
No.
Okay. Brooke, why is it 0?
Because it's a constant.
Because it's a constant. And so the instantaneous rate of change of a constant is 0. The derivative of a constant is 0. And that's what's going to make this problem maybe seem a little weird that there's a 0 thrown in there. Constant, unchanging, like the graph of it. Or if you think of the graph of y equals 7, what's the slope of that graph?
It's not
7. And then 0.
You mean 0. The slope is 0. Luna, what's the derivative of g?
3x squared.
3x squared. Okay, so gf prime, it's almost like I have to see it written down, minus fg prime over g squared. So g, x cubed plus 8, f prime, 0. So that looks weird, but that's actually good news, because what does that do? It just kind of wipes that part out. Minus f times g prime all over g squared. And by the way, that is a safe stop, even though there's a 0 there that wiped a bunch of that out.
What if you're just simplifying?
But almost certainly the multiple choice is going to say negative 21 x squared over x cubed plus 8 squared.
And you take out square.
And we're not quite done with that problem. Is that your question? So what's left to do? I got to plug in 2. So I was rereading the question to make sure I answered it. Like, you need to get in the habit of that with calculus, because these problems take a few minutes, and you get so caught up in finding using the quotient rule and simplifying. You get there like, whew, got it done. I'm good. Whoops.
And then
No, you're not. I got to plug in 2. Ty?
Can you take out the square or no?
No, you cannot cancel those squareds. So h prime of 2. Oh, there's a safe stop in my very near future here. Like now.
2
Did I mess
cubed
something?
plus 3.
Oh, yep.
You can't just quit halfway
Yeah,
through.
it's just that was done. Yeah, I don't even want to mess with that. Safe stop. Multiple choice would clean it up, and so it's not hard. I could figure it out if I needed to, but why bother? Leave it. Something might reduce, but not worried about it.
Couldn't you square root both? Or?
You definitely cannot square root top and bottom.
Because,
That changes the value of a fraction.
yeah.
All right, here at the bottom, higher order derivatives, mainly just about notation. First derivative is all we've done so far. Second derivative just means take the derivative again. Third derivative, take another derivative. And so this is what it looks like if we're asking for the second or third derivative. First derivative gets 1 mark, second derivative gets 2 marks, third derivative gets 3 marks. After that, it's like, wait a minute, this is getting ridiculous. Let's just put a 4 up there for the fourth derivative. We will almost never use 4, 5, 6, but we will definitely use second occasionally third. Most of our work is with first and second, though. All right, so it's like, what more is there to learn? Like, you've got to learn the derivative of f over g. That's the quotient rule. And you've got to learn the product rule. Product rule is pretty easy. One of them times the derivative of the other plus the other way around. And who cares what order they're in because it's adding. Quotient rule, though, we got to be careful to get the minus sign right because it matters in subtraction. Gf prime minus fg prime over g squared. So, today's assignment is the next worksheet in the packet. I think we're up to worksheet 5 now. Yep. Product rule and quotient rule.
We get out of here at 2?
We got at 1:58. So, 10 minutes left? Yeah. 12 minutes left.